I just had to let you know you're.
Good day everyone. For today's video, I am going to show you the correct solution and the correct answers assigned to me, which is the number 16 to 20. So let's start with number 16. Number 16. Compute the thickness of a 14.5 degrees per gear with a diametrical pitch of 5. So we have choices. A is equal to 0.23140 inch. B is equal to 0.31416 inches. C is equal to 0.43140 inch. And D is equal to 0.03140 inches. So to solve this, since we have a given of diameter pitch of 5 and we are going to solve for the thickness, so our given is the diameter pitch is equal to 5. So our solution in the circular tooth thickness is equal to T is equal to pi over 2 times the diameter pitch. So simply T is equal to pi over 2 times 5. So our T now is equal to 0.31416 inches. So the correct answer for this problem is the letter B, 0.3141 inches. On to our next problem, problem number 17. How do you call a structural member designed to support loads perpendicular to its longitudinal axis? Again, how do you call a structural member designed to support loads perpendicular to its longitudinal axis? A. Cantilever beam. B. Beam. C. Overhanging beam. D. Columns. The correct answer is beam. Why beam? Because in structural mechanics, a beam is a universal term for any member designed to resist transverse or perpendicular loading, which primarily induces bending, while the cantilever beam and the overhanging are just specific subtypes of beams, while the column is designed to resist axial or parallel compressive loads. So in this problem, the correct answer is letter B, beam. On to our next problem, problem number 18. Compute the speed of the gear mounted on a 52.5 millimeter diameter shaft receiving power from a driving motor with 250 horsepower. So, compute the speed. So, we have the given A is A 2,182 RPM, B 2,071 RPM, C 2,265 RPM, or D 2,341 RPM. So to solve the speed, we have given P is equal to 250 horsepower and we have D is equal to 52.5 millimeters since we need it to convert into inches. So in 1 inch, there is 25.4 millimeters. So cancel the unit millimeter. So we have now 2.0069 inches. So we have a solution. P is equal to d cubed multiplied by the n or the speed divided by 80. So since our unknown here is the speed or the RPM, we can rearrange this formula. So our formula now is equal to n is equal to 80 multiplied by p, then divided by, yeah, D cube. So, plug in the values, N is equal to 80, our P is 250 horsepower, while our D cube is 2.0669 inches cube. So, our N now is equal to 2,265 RPM. So, in this problem, our final answer is the letter C, 2,265 RPM. On to our next problem. Problem number 19. It is a load applied transversely to longitudinal axis of member. How do you call this load? Again, it is a load applied transversely to longitudinal axis of member. How do you call this load? A. Bending load. B. Combined load. C. Distributed load. And D. Cyclic load. The correct answer is A. Bending load. Why? It's because when a force applied transversely or perpendicularly to a member or to a member's axis, it creates a bending moment, forcing the material to flex or curve. This is the exact mechanical definition of a bending load. So in our problem number 19, the correct answer is bending load, letter A. So, on to our last problem, this is the very basic problem. Problem number 20. What is the load distributed over an entire area? Again, what is a load distributed over an entire area? So, the load distributed over an entire area. So, A, bending load. B, combined load. C, distributed load. And D, cyclic load. So, it's very simple. So the correct answer in the problem community is the letter C, distributed load. From the problem itself, a load distributed over entire area. So it is the C, distributed load.
I just had to let you know you're